All right. Okay. Good day, everyone. So first of all, I would like to thanks everyone, okay, for allocating your precious time to joining our webinar. Okay. So me as the host for today webinar, Zulfadli. Okay, I'm the iFactory Key Account Sales in Advantech Malaysia. Okay. So for today webinar topic is related to digitalization with Advantech, which using our 4C concept, okay, which is collect, connect, compute, and cloud. Okay, so in details later on, our assistant manager Halim Hamid will share you in details what is 4C is all about. Okay, so I will explain a little bit our agenda. Okay, so we will start with some Advantech 4C concept and overview. Then after that, we will go through some application story sharing. Then we will have a demonstration of our 4C concept, okay, with a real device and hardware. And after that, we will have a Q&A session. Okay, so while we will having the presentation, right? If any one of you have any question, okay, you can write down in the chat box, okay, and we will reply in the chat box, and also in during the Q&A session. Okay, then after that we will do some closing, and also I will announce for upcoming webinar, and also our survey form itself. Okay, so without further ado, we will start with our opening. Okay, so Advantech is actually a Taiwanese-based company, okay, was established in 1983, okay, and the industry that we serve all around the world is actually related to Industry 4.0, Industry IoT, embedded computing, medical, retail, and logistics, okay, because we cover a lot of industry, okay, we have thousands of products, okay, we have a 2,000 plus new product per year. Okay, and then we also is actually the largest AI PC company, industrial PC company in the world. Okay, so market share for Advantech is around 41%. Okay, up to 2022. Okay, our revenue is around 2.31 USD billion. Okay, we also do have our partners. Okay, we collaborate with our partners, for example, AWS, ARM, Micron. Okay, and also NVIDIA for the AI, NSP for the chip, and others OS or platform, so example as a Ubuntu, Trellix, and many others. Okay. As for Advantech, right? Okay, we are the hardware manufacturer. Okay, all of our hardware is manufactured by us. Okay, and then we have a two main manufacturing plant in Linkou and also in Kunshan in China. Okay, as for 2023, we have a market share around 8.3 billion. Okay, and we have a worldwide office all across the world. Okay, and for ASEAN region, okay, we have a branch office in Indonesia, in Singapore, in Malaysia, in Thailand, and also in Vietnam. Okay, so earlier this year, right, when during you're waiting for the webinar to start, you see some of the video, right? Okay, so one of the video is actually our grand opening of our Malaysia Advantech ASEAN Shared Service Center, ASSC. Okay, so basically this is our new building, okay, whereby we cater our repair centers, okay, our CTOS, which is configured to all the system assembly line, okay, to cater for all of the ASEAN customer itself. Okay, other than that, we have a training facilities, and also we have a IR 4.0 demo room and also development centers. So anyone you guys is near to our Penang office, you can drop by to have a look, okay, for to experience Advantech IR 4.0 demo room itself. Okay, so without further ado, okay, we will start directly to our next session. I will pass over to Halim Hamid.
Hi Zul, thank you for the very warm introduction. Hi everyone, I'm Halim. I'm the System Manager of Technical Team in Advantech Malaysia. So let me just show my face a little bit so guys know, okay, this is me. All right. So for the sake of the internet and all, for the continuity, I will turn off the camera for this session. However, during the Q&A session later on, I will turn on back the camera so that we have a more engaging interaction. All right. So what I will be sharing for today is basically number one is Advantech 4C concept. What is 4C concept? How does it comes to play in the industry 4.0? Then after that, after we understand the component of it, the component of industry 4.0, we look into the application story sharing, means that how customer has a pain point, how Advantech helps them to solve that by using a 4C concept. So in that solution or in that portal solution that we provide to customer, there will be some element of 4C in it. So we will go through one by one and we will identify the 4C, and also hopefully this will ever speed up your 4C journey for your own respective field. Then after that, after the application story sharing, then we will have a demonstration. Actually, this is a live demo that we have developed by utilizing a 4C concept as well. All right. So next one. So what is Advantech 4C concept and overview? Just now shared by Mr. Zuo, Advantech has a lot of product, up to 2,000 different kind of product, right? So we have a wide range of product. So how can we categorize it? Okay, first of all, we have something in Industry 4.0, right? The bottom layer, this is what we call a automation stack or Industry 4.0 stack. So you have eight sensing devices. So eight sensing comprised of wireless I/O, remote I/O, high-speed I/O, EtherCAT, gateway, and so on. So this all consists of collect element. So collect means it will collect the data from the sensor. So the mechanism from the sensor to this device are the same. They are still using 420 milliamp, using current, using voltage as the medium to transfer. But from there moving onward, how does it transfer to the next process or next station, right? So that is where the variety came into the picture. So next, after we already collect the data, so we will look into the communication side of things. How can we connect wireless? Means what is the central hub for wireless? What is central hub for wire? How about cellular and so on? So Advantech provides such a rich stack for this communication, right? In this sense, you can see connect element number two, connect. So we have a different type of communication. We have Ethernet switches, protocol gateway, serial device server, fiber optic, serial USB type, cellular type, wireless AP, and so on. So these to address a variety of needs in the industry. Next, after we have all of this data, right? So what we need to do? We need to compute the data. We need to do some calculation. We need to create some kind of localized dashboard. We want to do some kind of controlling. So how can we do that? Because different applications will have a different needs, right? So that is where we have a variety of that as well. We have from servers, industrial PC, fanless PC, PC-based controller, domain-focused IPC, which target certain applications. So that is the third stack, which is compute. Lastly, the last stack will be cloud. So that is the 4C concept in Advantech. So you have a collect, connect, compute, and cloud. So next. Once we identify these four steps, all right, so we have a collect element, connect element, compute element, and cloud element. Let's dive into that a little bit detail on that portion. So we go first with collect. So in collect, so the function of it, as I mentioned earlier, is to collect the data from the sensor. So you have a variety of sensor in the field. It could be a temperature sensor, any physical phenomenon, mostly we have a sensor for it. Temperature, humidity, pressure, flow, You name it, normally they will have a sensor for it. Then how the sensor transfer the data, it will usually it will convert a physical phenomenon to an electrical signal, either current or voltage, right? So what happens is the computer and all of the controlling devices cannot directly read from it because they don't understand the current reading, they don't understand the voltage reading. So you need something in between. We call it as DAC, Data Acquisition Module, DAC. All right. So Advantech, we have variety of DAC. Uh, for example, we have a wireless I/O solution. Means that the input is collecting data using a 4 to 20 milliamp current voltage and so on. But we transfer out to the next process, to the next stack using different wireless methods such as LTE-N, Wi-Fi, 4G, and a little bit niche, for example, NB-IoT, and now the quite popular communication LoRaWAN, LPWAN, and so on. Secondly, there are some needs for a high precision distributed control. So in this sense, you will need something that have a fast response time with a distributed architecture. So we have a control I/O solution. After that, if let's say you have a simple monitoring, but you want to use a wired base, so we have that as well. We have RS485, which is a serial base. We have Ethernet base with a lot of I/O. And also we have some niche I/O, for example, like for train and all that. So the advantage of using wired, for example, it can support multiple type of industrial protocols such as RESTful API, SNMP, Profinet, Ethernet IP, OPC-UA, Modbus, and so on. And lastly, sometimes customer would need a fast response time. It's very high precision, accurate analog sampling, for example, right? So mostly in that kind of situation, you would need a high-speed PCI card, high-speed USB DAC module. So this one meant to be attached with the control system, meant to be attached with the IPC, so that you have a fast response time. Normally, a machine maker, someone who producing a control system, they would prefer something like this because you have a most accurate reading, right? So each of them would have their own pros and cons. So wireless, for example, it's very easy to deploy. You don't have to think about the wiring costs and so on. Whereby for remote I/O, right, the advantage is you don't have to care about the data size because anything can go through a Ethernet-based protocol. You can send it out. So you could have a real-time data. But let's say you want to have a more accurate reading, then you will prefer or opt for data acquisition solution, right? So that is for the first C, which is collect. Then we move on to the next C, right? Is connect, right? So now we already got the data, right? I got the data using the DAC module, either using wired, either using wireless, using a PCI base, and so on. So how do I connect between them? Right? So we have a rich industrial networking portfolio, all right, that following up-to-date trend of communication in all devices, equipment, and machine. So each of them would increase the productivity, efficiency, and scalability of your project. For example, we have gateways for wireless. We have a serial device server for wired serial base. We have a different type of switches. Okay, we have a media converter. Media converter, for those who not aware of it, it is basically for you to convert from one medium, which is a serial or LAN based RJ45 to fiber and so on. You can convert the protocol as well. We have a most basic unmanaged switches. We have a L2, L3 switches. We have switches for specific domain. For example, for substation, they have a specific requirement. We have that as well. And we have a very high sensitive timing switches, which is a TSN. Also, what we have is for the train because train they have a little bit of niche requirement. For example, they need to have a certificate of EN 50155. All right, so we have that as well. Then in terms of industrial routers and gateway, we have a lot of stacks. So we have a 5G router, and this has been endorsed by DNB. All right, so we one of the 5 vendor that has been endorsed by DNB that certified to use. We comply with both SA and NSA. So it means basically it complies both standard of 5G. Then we have a LTE. So our router is just it is not only just a router. We can install a small package module that we have built. For example, to convert certain thing to do a certain processes. So you could do that as well. And we have a communication gateway, right? For example, to communicate serial and transport using LAN. From serial, we want to send out data using MQTT and so on, right? So that is for the networking stack. So now we move on to the next stack. All right. So the next stack would be a compute. All right. So now in Advantech, right, as shared by Mr. Zul earlier, we are the market leader in industrial PC. Okay. So basically what I can say is you name it, 90% of the time we have it, right? So we have from small size industrial PC, right? This is as big as my palm. It's very small, very lightweight, all right? It is a DIN-rail IPC up until power and IPC or server type of application. So you can see we have a DIN-rail, embedded box, compact IPC, wall mount, rack mount, tower PC, panel PC, and so on. So why we are quite strong in this? Because of 4 reasons. Number one is the serviceability, right? We have a option for domestic configuration to order. Means that you have a certain configuration, certain type of requirement that you need. We can satisfy that requirement. Secondly, we have a customized design to order. So we can custom based on your requirement as well. And we have a longevity and revision management. Our cycle time or life cycle of one product usually more than 5 years. We have up to 7 years, 10 years of product still running in the market. So in the PC world, right? If you are familiar with PC world, that is quite rare because most of the time, if you want to purchase a 2 years back processor in a normal market, it's quite hard for you to find. Now it's 13 gen, right? If you're trying to find a 10 gen processor, for example, good luck finding a new one is quite hard to get it, right? So that is quite important as well. The second aspect is on the scalability, right? Most of our IPC comes with something called IDOR innovation. IDOR innovation is, if you see over here, we have some slot, right? So let's say in this requirement, you need 4 LAN port. If you see over here, we have only 2, 1 and 2. Right? So how can we do it? So if other PC, we might use other adapter and so on, but for IDOR technology, we can put internal adapter, so it will be equipped with number of IO that customer needed. Secondly, on the GPU qualification, all right? So all of the GPU, we have a stat list of GPU that we sell, and we already tested it with our PC. We tested in terms of heat flow, in terms of the performance of the GPU with a certain model and so on. So that you don't have to do this thing, we already validated that kind of important parameter on your behalf. Thirdly, we have some of our PC have a modularized expansion. It means that you can extend it. Not only 1 port or 2 port, we can extend a PCI port, PCIe port, for example. I mean, we can have a double stack. So this one is a 1 stack. Then modularized expansion means we can add another stack in. Right? The stack also, we have a single stack, we have a double stack. So it will be quite convenient. We maintain the small form factor, However, we have a higher I/O, higher input/output that we can slot in. Right. Third would be the inter in interoperability. So in this case, right, so we able to communicate with most of the industrial protocol, for example, core disease control, H-link data aggregation, which is our own proprietary software, whereby it can manage and collect data from different type of machine, different type of protocol, up to 200 types of protocol. And it can work with our WebSS SCADA as well, whereby it would provide a localized dashboard with a data acquisition function as well. So lastly, on the manageability, all right, we have something called IBMC OOB control. So IBMC OOB control, mostly they introduce it in server, whereby if let's say something happened to the OS, okay, how can you debug from remote, right? If you cannot access the OS, by default, you cannot access the device. However, for IBMC, you can access the device lower than the OS level. Means that if let's say something happened to your Windows, you still can remote access up until the BIOS level. So this would be very convenient. For example, you have installed your machine located quite far away, Sabah, Sarawak, and so on, or maybe in different countries, right? So by having this type of thing, you can save a lot of cost. To have an initial troubleshoot and make you more prepared in what's happening or how can you tackle that issue. Secondly, we have a voice device on remote control. It is basically a centralized platform that monitor all of our PC. It means all of our PC comes with this device on agent. Now we change the name into H-Think 360, whereby you could have a centralized monitor the health of the device. Thirdly is for SNMP agent monitoring. So SNMP agent monitoring, basically, if let's say you already have a third party monitoring tool, we can collaborate or connect to your third party as well. So that is mean by SNMP agent monitoring. So that's just to show a little bit of our portfolio. This one is only on our HMI, which is a human machine interface. Normally HMI is a ARM-based processor, okay, or sometimes we have a Windows-based that have a screen as well. It has a panel as well. So in this sense, normally it will be located at the machine or at the production site to control the output input, to control the flow of the process, and also to have an alert and alarm at that particular machine. So we have a different kind of type of HMI. We have a standard operator panel, we have a web terminal, we have a standalone all-around control panel. We also have a explosion-proof HMI, C1D2 or attached. So this one can be used in a hazardous environment, for example, for oil and gas environment. Okay. So now, next, the last portion would be the cloud. So imagine you have a localized dashboard. Each of the machine will have its own dashboard, right? You have a machine number one, it has own dashboard, machine number two, machine number four. So in one production line, we have a lot of localized dashboard. So you need to bring this over into one centralized monitoring. So you can use something called SCADA. SCADA stands for Supervisory Control and Data Acquisition. Means that it will collect the data from different HMI, different control panel, control IPC, and put it in more centralized overview. And it has basically 5 functions. Number one is the data acquisition side. So it can support a lot of protocol, okay, and it also support up to 400 different kind of drivers. It support a redundant architecture and so on, right? So this is one of it. And you also can send out to your existing database, existing MES, ERP, and so on. It means that it becomes your middleman. It can give you a dashboard. At the same time, can send out to a different service, it can send out to a different vertical, and so on. All right, then you will have some issue if, let's say, the dashboard that you have is only localized, right? You will have some issue. Let's say you have 3 plants. So you install SCADA in one of the plants, and you install SCADA in another plant, and you install SCADA in the third plant. So what happens is all of this SCADA does not talk to each other. You need to have one centralized point that can view all of that together. So that's why the cloud came into play. So we have something that is pre-built called TPM, Total Productive Maintenance. So under this portfolio, we have 6 different solutions. So we have OEE, Overall Equipment Efficiency. Then we have NDOT. Next, we have iFactory Maintenance, which is to maintain the machine maintenance and repair strategy for planning to reduce the machine downtime. Then we have a shop floor, e-manual, and SPC, right? So in my demo later on, I will focus more on OE because our demo is based on the OE, Overall Equipment Efficiency. So basically what is OE? OEE is an indicator of the healthiness of your production floor. So it consists of 3 things, which is availability of the machine, the performance of the machine, means the target output, does it reach the output or not, and third point is the quality of the output, means the yield. For example, in 100 batch, how many of them are good, how many of them are bad, for example, right? So it will compute into one singular number in terms of percentage. So based on the percentage, you would roughly guess, you could roughly know that, okay, my production running at optimal level, or am I lagging behind, and so on. Later on, I will explain more in the live demonstration. Right, we also have a pre-built stack for energy management. Now people talking about carbon reduction, ESG, and so on, right? So we have a multiple solution for intelligent energy management. So we have up to 2 levels. Level 1 is for the smart management. We have EcoWatch, HVAC, compressor, and power management. And number 2 is on the sustainability management, means the carbon reporting and so on, right? So we have this total of 5 types of vertical solution for your site to explore this. All right. So lastly, we have HSync 365, or the previous name is device on. So what happened is, if let's say you purchase device from our company, for example, from Advantech, all of our devices, doesn't matter industrial PC, Advantech IPC, and also Advantech IO modules, right? We can send out to this platform to monitor the real-time and remote control. Secondly, we can do a OTA, firmware update, configuration update, application update, and so on. Third, we can do a dashboard and alarm notification. Fourth, we can do authentication and instant onboarding. 5, it has an enhanced security with VPN and MQTT. And third and 6, we have a virtual physics model. Right? So why this is important? What is the value of this? So I give you an example just now, right? When you have an IBNC, easy for you to debug and see the problem and so on when you're having an issue. But that only occurred, I mean, you can only notice it after the issue already happened. So the advantage of HSync 365 is it will give you some alarm, some indicator before the hardware or before the product having some issue. For example, the simplest one is normally when you have a product that having some issue or faulty, right? The first indication would be the temperature will go up. Right, so we could do some alarm threshold, right? That notify us, this particular device has some issue because the temperature is beyond the acceptable level. So that is number one. Number two, we can directly go into the device and check, okay, what's happening? Is it we have a wrong configuration and so on, right? So let's say in this case, oh, this is because of the current firmware having some issue, then we need to update the firmware. So we could just update over the air. We don't have to go to site to install it, to update the firmware and so on. All right. Okay. Now we move on to success story. So in this success story, I will share a total of 4 success story. Okay. So each of them, I will explain what is the pain point, what is the challenges, and how Advantech solve this issue and the project benefit of it. And along the way, we will identify the 4C elements in this success story. Okay, number one is the success story is in Malaysia, whereby CNC monitoring with AGV system. So customer pain point, customer said that they don't have a real-time data from the CNC machine, such as status, alarm, availability, and so on. So they're not sure how many machines are running in their production floor. Let's say they have a 20 machine, how many are running, how many having a downtime, how many in the repair process, idle, and so on. What is the utilization? They don't know. Secondly, they have a lot of lost time in changing material, jig, and drill bit. So what are the challenges in this project? So number one is to integrate with AGV to monitor material rack status. Number two is to provide a wireless connection to CNC machine, right? So how we solve it is, first we put a data acquisition module to collect the data from this machine, and this machine will interact with this controller so that when it indicating something, like for example, the thing is below the threshold, it will send out some command to this controller, and this controller will prompt the AGV to take the part and so on, right? So what is the project benefit of this? Number one is customer now have a real-time CNC monitoring. Number two is they can monitor the material rack status for AGV usage. Number three, they can improve their quality and also productivity. So now let us see the 4C element in this. Let's change it. All right. So number one, this is the first C. We have a collection stack. All right. So this is the first C. We have collection stack. We use this one to collect the data from the machine. Okay. Then next is on the we could say the Apex is a collection stack as well. All right. So this is the data that interact directly to the machine itself. Second, on the connect element. So on the connect element, let me change the color. So we have this one, the wireless I/O. So 1, 2, 3. All right. The function of this EKI is as a wireless AP, whereby it will send out data from wired to wireless. So from wired to Wi-Fi bit. And third would be this one. This is on the compute side. So this one as a controller that view all of the status, dashboard, computational, and so on. So in this case, customer opt for on-premise solution. So in terms of cloud solution, they use a on-premise type, right? Right. Next. So what is this customer's spend point? Number one is they want to do a wireless machine tower light system monitoring. So customer pain point is they cannot track and log what is the root cause of machine downtime. All right. So the challenges of this is they have a dynamic production floor. They don't want to do any extra wiring for new system because the production floor might change depending on the product and so on. So it is quite impossible to do extra wiring because the layout can be changed. So how can we solve it? We use our wireless DAQ module, collect the data from the tower light. Then we use our EKI as an access point to collect data from multiple DAQ module. Then we send out using a switch, and lastly to the control system. And finally, to have a centralized dashboard, they send it to a cloud monitoring platform so that easier for them to view it from outside and easier for them to manage it as well. So the project benefit is they're able to monitor the machine status. It allows end user to do reasoning for machine downtime, and it is suitable for dynamic production flow. All right, this is the third example, intelligent fire alarm system and facility monitoring. So this case, we successfully spec in Indonesia. So what they want to do is they want to monitor multiple type of sensors such as fire detection, temperature, humidity, alarm, buzzer, and so on. All right. So they want to have a early detection. So the challenges, the system must be able to give early warning notification when it detects fire. The system must be able to run 24/7 without any failure, right? So by using our DAQ devices at the over here, right, it is very reliable, number one. All right. And also by using LAN, we're able to give a early warning detection. It will not have any delay, such as wireless, you might have some delay, but for wired, you could have a real-time data monitoring. So what is the project benefit? First of all, is it allows customer to have a remote monitoring and management. It allows customer to have alarm log and also historical data, Excel reporting, and it allows customer a lot of client to view the dashboard without any additional cost, because one of the advantage of using our web access SCADA is that once you install in this PC, right, it allows a concurrent user to view the dashboard. For example, you have a 3 department, production department, engineering department, and management department, right? So each of them could view the dashboard at the same time with a different hierarchy. For example, production could see a certain portion of the dashboard, whereby the engineering and also management could see a more comprehensive dashboard. For example, we could do that multi-tenancy kind of arrangement. So for last case, all right, which is the process and power monitoring system, right? This we able to spec in Indonesia as well, all right. So what is the pain point? Number one is expensive cost of substation control and monitoring system, and the reason being is because it is an extreme environment, all right. Then they need a powerful RTU that can be integrated with the existing main SCADA, all right. So in this substation control, number one, of course, the location. For substation, normally the location is at the remote area. All right. Number two is we need to have a large configuration setting after power off. Number three is integration with customer SCADA through DMP3 protocol. So DMP3 protocol is a widely used protocol for power and energy sector due to several things. All right. So how can we do this? We spec in the collection module Adam3600, which can collect data from the I/O, for example, DI, 4DO, 8AI, right? Then it can send out the data using DMP3 protocol, which complies with the customer requirement. At the same time, we also have a substation control PC that complies with the substation standard, which is IEC 61850-3. So it complies with this substation requirement because we have a lot of variety of specs, of configuration, of PC and so on, right? That able to comply with customer requirement. Okay. So that is for the successful case. Now we move on into the demonstration. So before I showcase you the video of the demonstration, let me explain a little bit. What is the demonstration is all about, how the connections are going, what is the system architecture, and so on. So our demo is based on the overall equipment effectiveness, as I mentioned earlier. So basically in one machine, right? You have these three things normally. Number one is you have the PLC. So PLC is the machine controller, is the heart of the machine, is the brain of the machine that controls the in and out, the flow, how the machine compute the data, count the data, and so on to give instruction to the machine, right? Then you have some kind of indicator, either it's running or not running and so on. So 90% of the machine, they will have this something called tower light. So tower light will be installed somewhere around here so that the operator or even the supervisor at the production site, at first glance, they could see, okay, either it is red, yellow, or green, same like our traffic light. All right. So if green means the machine is running, if red means the machine is not running, if idle means that the machine is on standby, right? However, this data is not, it's called island data. The data is stagnant just over there, right? So that is one of the pinpoint of it. Third is temperature sensor. So this mostly on the preventive side of things because uh, to have the machine what we call machine temperature, right, is very crucial because mostly that is the first indication of something wrong with your machine. Means that the temperature is goes up. Same like our car. Suddenly out of nowhere when we are driving, the temperature goes up. That indicates something's wrong, right? Either our radiator having a problem, having a leakage, and so on. Right? So what we do is we try to simulate something. We show that okay, we can collect the data from the tower light using our tower light sensor. Then we send out to our wireless DAC just to show the flexibility of our IoT gateway. So we collect the data using wireless DAC and it send out data wirelessly to this IoT gateway. Number two, the PLC and also the temperature sensor, they can connect directly to the IoT gateway because it has a low level, they have a high level protocol, which is they're using a serial communication, the widely used in the industry called Modbus. So when they use this one, we don't have to put any DAQ in the middle. We can directly tap in this IoT gateway. Then after that, to have a localized dashboard to control on and off, how to control everything, we send this data to our Advantech HMI, which is a localized dashboard. Lastly, you have a more centralized dashboard monitoring. You have a 5 dashboard, 10 dashboard, 10 machine, 5 machine, and so on. So we want to complete that into one centralized dashboard. So we send it to Advantech OEE, which is the overall equipment everything. This is where they calculate the availability, they calculate the performance, they calculate the quality, and so on. Yeah, so this one is directly connect to the cloud and it uses MQTT. Right? So let me share to you the sample, the demo video.
Hi, it's me again. I would like to now, after we go through all of the theory part, what is 4C, collect, connect, and all that, how can we relate that to a real life application? So here we have a live demo, whereby what we like to do is to monitor the production effectiveness, something called OEE, overall equipment effectiveness. So in this demo, my purpose is trying to relate back the element of 4C in most digital transformation. Okay, so as you can see in a production area or in a production environment, normally they have something what we call as PLC, which is the controller of the machine. So in this demo, we have the controller as well. And secondly, we have a temperature sensor to monitor, to simulate back the environmental monitor of the machine. And thirdly, the machine status. Alright, so now we see, so this is the heart of the machine, right? So we create a simulation of a machine. If you see here, simulation of a machine. So this is the heart of the machine, the PLC. So we have a temperature sensor and also a tower light status. Normally tower light status will have around 90% of the machine will have this tower light sensor to indicate what is the current status. So it can be either idle, running, or stop. Okay, so let me just go through briefly the simulation of this. So first we put a target quantity. So let's say our target quantity is 15. Okay. Alright. Then after we do that, we start the machine. So once we start the machine, you will see the status run change. So that proportionate with the status from the tower light itself. So this information can be tagged using our tower light sensor, and it will send the data. Alright. So after the actual quantity is tally with our target quantity, so it will promise, okay, how many reject quantity. Alright, so we key in, let's say we have 2 reject quantity. Yeah. Alright, so the system will re-record it that, okay, in that 15 production batch, we have 2 reject quantity, and it will go back to the centralized dashboard. Okay, let us press start again. So we have another function for alarming. Normally, if let's say machine is running at a higher capacity or something issue with the mechanical part and all that, the first indicator would be the temperature would be higher than normal. So let's say we put a temperature set point is 26 as an example, and this is the actual temperature. So you can see that, okay, the status changed to red, and we have an alarm. So this will be recorded to the system as well. So that is the flow of this demo. Alright, so now we have understand the flow of this demo. Okay, how does all of the component, the PLC, the temperature, the set point place into actual production. Next, how can we relate back to a 4C element? So number one is we need to capture the value from this tower light. So this is the first element, collect, whereby we are using our tower light sensor and also send it wirelessly using WISE2200. So this is the first element, collect element. Next, we need to have a connect element. So some of the controller like this PLC and also temperature sensor, they have their own interface. Means that you can directly connect to a controller to get the value. Alright, so in this case, we need something like this, our IoT gateway, that can connect all of these elements. It becomes the hub for all of the data acquisition, and it can send out into a next process. Alright, so next we have is HMI. Okay, HMI stands for human machine interface, whereby this is the layout or the localized dashboard that you will see located at the machine. Alright, so this is what happening in your production environment, that's happening for that particular machine. Alright, so now the last element would be cloud. So for cloud, let's say you have more than 5 machines and each of them would have one HMI. So how can you see in the overall of effectiveness of 5 machines? So you need a centralized dashboard. So that's why the centralized dashboard or the last element, cloud, came into play. So cloud doesn't mean that it only can be on cloud, it can be on premise as well. Okay, so lastly, as I mentioned to you, if let's say we have a lot of HMI, so we can send out all of that data into one centralized dashboard. So in this page, you can see that it will list all of your machines. For example, you can streamline by the what is the production, what is the area, department, and so on. So it will have a total computational over here, and each of the machine. But currently we only have one demo, so that's why we have a one demo over here. So if we want to detail out individual machine, so we can go over here, then we can check on here, then we can go into each individual machine. So what is the ability, what is the performance, what is the quality, production time, idle time, error time, the production history, the trend, quality, we can detail out and have all of the information over here. Okay?
Alright, so that's it for the video. Alright, Zul, I pass back to you.
Okay, thanks Halim for the in-depth explanation. Okay, so I think we can do the closing. Okay. Okay, so basically for today webinar, right? Okay, it is only for the introduction of our 4C concepts. Yeah. Okay, so in the next 4 webinar, we will go in deep. Okay, we go in details for each of the C itself. Okay, so example, the next webinar will be the collect, right? So we will go in details. What are the things inside this collect concept itself. Okay, and then we will also sharing details on how to properly choose, okay, which are the product is suitable for your needs. Okay, then after that we will go to the connect, compute, and also last will be our software itself. Okay, so okay, so this is another webinar that we will have on next week. Okay, so we have a two webinar will be in the next week. Okay, one is related to the AI, okay, generative AI. Then after that, abnormal event handling, which is our end-on system in our WhatsApp factory itself. Okay, so before we end our webinar, right? Okay, so we do have a survey form. Okay, so hopefully everyone in this webinar itself can scan the QR code using your mobile phone. Okay, and then fill in the survey form. Okay, this is to ensure we will know how efficient is our webinar and how to improve our webinar for the next session itself. All right. So thanks all, okay, from us, from Advantech, okay, for every one of you guys for attending this webinar. So, Mr. Halim, do you have any you want to say to the audience?
Okay, so thank you very much. So I hope that you'll be able to get something out of this webinar, number one. Number two is if you have any question, any concern, feel free to put it in the chat or maybe email to your sales representative. We will try and look into it because I think that as Advantech, we have a lot of rich ecosystem, means in terms of the 4C level, wired, wireless, and so on, right? So this might be a door opener for your side, especially in new emerging countries. So we also looking forward to have a more collaboration with your side. Yeah, that's all for me.
Okay, thanks everyone for joining the webinar. Okay, so remember that next week we do have our webinar, and also remember that we have a next series of forces webinar. Okay, our sales representative will invite you, okay, to register for the next webinar. Thanks everyone. Have a good day.
Okay, thank you. Bye bye.